Hello, ladies and gentlemen. Are you tired of all of the times that I've said, we're going to learn something brand new yet this chapter? Hopefully you're not, because we're going to learn something brand new today. So today we're going to talk about an entirely new way of measuring angles. All right, we've measured angles in degrees for our whole lives so far. That's the only way that you have of measuring angles. And it works pretty well, you know. There are 360 degrees in a circle. We know all of our degree measures, 180 degrees and so on. But we are going to talk about a more mathematical, more scientific way of measuring angles today. All right, and that measurement is called radians. And radians are a unit of measures, and they're a unit of measure that's only applied to angles. And really only applied to angles in the coordinate plane, like angles on the unit circle. We talk about radians when we're talking about angles from the center of a circle. And they're useful in rotation, like if you're thinking about physics and the rotating of a wheel or the rotating of a drum or some kind of rotation is where radians are really helpful for us. Because what radians do is they give a very sort of precise way of measuring the position of a spot on a circle. So the position of a spot on a wheel as it's rolling or something like that. Radians are useful. They're just kind of weird. So what we're going to write here is a radian is a unit of angle measure. A unit of angle measure. Hi, Mac. And the thing that we're going to talk about, or one of the things we're going to mention, is that there's no symbol for radians. Degrees have a little circle degree symbol, but radians don't have any symbol. Radians are a unit with no symbol. All right? So we're going to say with no symbol. So how big is a radian? Radians are a different size than degrees are. Okay? Radians are a lot larger than degrees. So the way that we measure is we start with thinking about a full circle, right? And we say that in a full circle, there are 2 pi radians. Weird, right? It's so strange. You'll kind of see why tomorrow or in the next section of notes that we do, but it's weird that there is 2 pi of anything in a circle, and we say that that's easier to use than 360 degrees. But we'll show you, as we continue on, why that is a useful measurement. All right, and from there, we break down the radian into other amounts, all right? So if there are 2 pi radians in 360 degrees, there are just 1 pi, or pi radians in 180 degrees. So if we start at 0 on a unit circle and we go halfway around, we've gone pi radians. Remember, pi is just a number. It's a number that means 3.14, etc. So if we go from the 0 mark all the way over, we've gone 3.14 radians. Okay? We can continue breaking this down. We can say that 90 degrees is equal to pi over 2 radians, because it would be 180 degrees divided by 2, or pi divided by 2. And we can even talk about how big 1 degree is. So if there are pi radians in 180 degrees, then in 1 degree, there are going to be pi over 180 radians, right? If we take our 180 degrees, divide it by 180, then in 1 degree, there are pi over 180 radians. We're going to need that measurement because we're going to be able to convert from degrees to radians using that measurement. So if we are going to change these degree measurements into radians, we're going to use this idea. If we know that 1 degree is equal to pi over 180 radians, then 45 degrees is equal to pi over 180 radians multiplied by 45. So in each of these problems, we're going to take our degree measure and multiply it by pi over 180. Okay? And so that's going to be like 45 pi over 180. And then we can just figure out, okay, how big actually is that? So 45 pi over 180. We want to reduce this fraction. All of our radian measurements should be in reduced fractions. So 45 over 180 reduces to 1 over 4. So we're going to say that this is pi over 4, or 1 pi over 4. So 45 degrees is pi over 4 radians. All right, negative 90 degrees, same thing, multiply by pi over 180. And we get negative 90 over 180, which is the same thing as negative 1/2. So we can say negative pi over 2, or negative 1 pi over 2 radians. All right, and again, notice I'm not putting any symbols here because our radians don't have a symbol. All right, 310 degrees times pi over 180 is going to be 310 pi over 180, but we want to reduce that fraction, so we can divide by 10 and we get 31 pi over 18 radians. And then finally, we've got 239, a strange number of degrees. If we multiply that by pi over 180, hi Mac, we get 239 pi. We get 239 pi over 180. All right, and that is unfortunately something that doesn't simplify, so that is our number of radians, 239 pi over 180 radians. At this point, you're probably going, why is this at all useful? These are much simpler measurements. And I wouldn't disagree with you at this point. We're going to learn about radians before we really get into the applications of radians. We're going to talk more about the applications of radians tomorrow, or the next time that you get a section. So it's okay if these seem kind of strange and useless at first. We can also convert radians into degrees. All right, so if we have a number of radians and we know that there are pi over 180 radians in 1 degree, we can take a radian measurement and multiply it by the reciprocal. Okay, we can multiply it by 180 over pi to turn it into the number of degrees, because we're taking our number and multiplying it by 180 and we're canceling out the pi. So this is going to be like 180 over 3 because our pi's cancel out, and that is 60 degrees. So pi over 3 radians is equal to 60 degrees. 4 pi over 3 times 180 over pi. Got 4 times 180, that's 720 over 3, which is going to be 240 degrees. All right, 11 pi over 6 times 180 over pi. It's going to be, let's see, 11 times 180 is 1,980 over 6, which is equal to 330 degrees. All right, and then negative 2 pi times 180 over pi. That's negative 2 times 180, that's negative 360 degrees. So degrees to radians and radians to degrees are 2 measurement conversions that you'll have to know how to do for the future, especially for Algebra 2. So make sure that you are able to keep track of those. Remember which way things go. You multiply by pi over 180 on the first set. You multiply by the reciprocal, 180 over pi, on the second set. The next thing that we are going to do is we're going to incorporate radians into our unit circle. So if you remember in the last section, there was an extra set of blanks on the unit circle that we didn't fill in. But now we can fill those in because those are radians. So we're going to fill in the radian measurements on this unit circle so that we can use it to calculate some of our some of our ratios that we need to find using trigonometry. So we can start here. 0 degrees is the same as 0 radians, right? 0 degrees and 0 radians are the same. And we also said that this line, 0 degrees, that's the equivalent of 360 degrees, going all the way around. 360 degrees is the equivalent of 2 pi radians. So this line is either 0 radians or 2 pi radians. We also talked about how 180 is going to be just pi radians. Oh my goodness, my cat. Okay. She is knocking things over. So we've got pi radians over here. And then right in the middle of 0 and pi would be pi over 2. So 90 degrees is pi over 2 radians. Matt, can you be quiet just for like 5 minutes, please? Thank you. So we've got pi over 2 radians here. And we can follow that pattern. So if this is 0, pi over 2, 1 pi, 270 degrees is 1.5 pi, or 3 pi over 2 radians. And then we can keep going. So if 90 degrees is pi over 2, half of that, 45 degrees, is pi over 4. Okay? And that means that each set of 45 degrees is pi over 4 radians. So 0, 1 pi over 4, 2 pi over 4, which was simplified to 3 pi, or pi over 2, 3 pi over 4. We'll go to 180, that's 4 pi over 4, or just 1 pi. Then 225 is 5 pi over 4. Then 6 pi over 4 for 270, and again that's simplified. 7 pi over 4 for 315. And then back up to 8 pi over 4 for 2 pi. And then let's get our 30-degree intervals in there. So if 90 degrees is pi over 2, and we have to split it, Mac, holy goodness. Okay, and we have to split it into groups of 3, right? There's 3 sets of 30 degrees and 90 degrees. So if this is 1/2 pi, then pi over 6 is 30 degrees. 1/6 pi is 30. So pi over 6, and then we can continue that thread counting by pi over 6's. So if 30 degrees is pi over 6, 60 degrees is 2 pi over 6, which is the same as pi over 3. 90 degrees is 3 pi over 6, we already got that. 120 degrees is 4 pi over 6, which reduces to 2 pi over 3. 150 degrees is 5 pi over 6. 180 is 6 pi over 6, we got that. 210 is 7 pi over 6. We're just adding a sixth each time here. 240 is 8 pi over 6, which reduces to 4 pi over 3. 270 is 9 pi over 6, which reduces to 3 over 2. 300 is 10 pi over 6, which reduces to 5 pi over 3. And then 330 is 11 pi over 6. So 11 pi over 6. So we've got all of our radian measures in here. And now we can use the unit circle in exactly the same way as we had before. So to calculate using radians, we can do everything the same. We can go around the circle more than once if we need to. We can go around the circle backwards if we need to. Anything we need. So I see that I need to find the sine of 3 pi over 4. So I'm going to go and I'm going to find 3 pi over 4 is right here. And we remember that these two coordinates are arranged in a way that this first one would be the cosine of the angle and the second one would be the sine of the angle. So if I'm finding the sine of 3 pi over 4, it's just the square root of 2 over 2. All right, the next one's a little bit trickier. So square root of 2 over 2. Here I've got tangent of negative 5 pi over 3. So if I'm not very familiar with the unit of radians, I might check to see how much that is in degrees. So if I find 5 pi over 3 here, that's 300 degrees. So a positive 5 pi over 3 would go around, 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 and end up here at 5 pi over 3, or 300 degrees. A negative 5 pi over 3 would start at 0 and go around that same amount. And again, you can think of it in radians if you want, or you can say, oh, that's like 300 degrees. So it's like I'm going negative 300 degrees. So go around 300 degrees and we end up here at 60 degrees, or just pi over 3. Right? So pi over 3 is the same as negative 5 pi over 3. And to find the tangent of this, we would do the sine over the cosine, right? Sine divided by cosine, or opposite divided by adjacent is going to be the tangent measurement. So our opposite is the square root of 3 over 2 divided by our adjacent of 1/2. I'll write that here. And then we've got a fraction divided by a fraction. We're going to multiply by the reciprocal. So square root of 3 over 2 times 2 over 1. That's going to make our shoes cancel out, and we get the square root of 3. So the tangent of negative 5 pi over 3 radians is equal to the square root of 3. All right, and then we won't do this very often, but I wanted to mention to you how to use your calculator to find these. So if we are going to look at this, we want to say we need our calculator to be in radian mode. Up until now, we've used a calculator in degree mode, and now we're going to start switching back and forth. So make sure every time you do a calculation that your calculator is in the correct mode. So remember, to change the mode, you go to the mode button, wherever it is on your calculator, and you go down here and you make sure that radian is highlighted. Hi, Mac. So you go down there and you make sure that radian is highlighted, and you can hit enter if it's not. And now if you do cosine of 1, instead of thinking that that means the cosine of 1 degree, your calculator is thinking, all right, that's the cosine of 1 radian. All right, and the cosine of 1 radian there is 0.54. So it's the same way as we were doing with calculators to find the trig ratios of degree measurements. We just need to make sure that we are in radian mode instead. Same thing here. Forget this -1. We can't actually do inverse sine of this value, and we'll see that tomorrow why that's true. But we can do sine of 8 pi over 3 radians. So we can say the sine of 8 pi divided by 3 is equivalent to 0.866. So 0.866 is going to be this answer. And of course, that's actually not an exact answer. We could find an exact answer for the sine of 8 pi over 3 using our unit circle. And you can try that right now if you want. But you have enough stuff now that you can go ahead and work on the homework worksheet for today. So go ahead and work on that. If you've got any questions, let me know. Thank you.